This will be a review of exit slip 11, where we talk about the domain and vertical asymptotes of rational functions. So let's walk through these. Basically, a good starting point is to focus on setting the denominator to 0, because we know we don't want that to happen. So whatever value of x makes the denominator 0 will be the vertical asymptote, and then the domain will be everything else. In this first example, setting x plus 2 to 0 means that x equals -2 is the value that would cause the function to be undefined. So the vertical asymptote is x equals -2. So whatever setting the denominator to 0 and solving gives you, that is the vertical asymptote. So actually a lot of times I just state that first. I know the directions kind of indicate domain and then vertical asymptote, but the order in which you find them doesn't really matter. So from there, I personally like to then state my domain as everything but that. So my domain could be expressed in a set builder notation as all x, such that x does not equal to -2, right? We're excluding the value of the vertical asymptote. Or my interval notation, folks, you can write -infinity to -2, and then jump over -2 and continue to infinity. So either one of those notations would be great for the domain. So that's about all there is to it. At this point, we're just kind of looking at domain and vertical asymptote. The next step will be to start looking at horizontal asymptotes and then graphing. But for here, we're just focused on the vertical asymptote and the domain. The next one, again, similar approach. Let's just snag the denominator of this function, set it equal to 0, and consider our solving technique. You can tell here this is a quadratic equation, so there are going to be two solutions. It looks like the technique of factoring works well. So two numbers that multiply to +8 while adding to -6 would be -2 and -4. So we find either x equals 2, or x equals 4. And those will be the two vertical asymptotes for this function. So this has two vertical asymptotes. From that then, the domain will be everything but those two values. So in a set builder notation, all x, such that x does not equal to 2 or 4, will be sufficient. My interval notation, folks, this is going to take 3 intervals from -infinity to 2, unioned with 2 to 4, unioned with 4 to infinity. So we just popped over 2 and 4. So even though the solving was a little more complex than the first example, hopefully that feels still fairly straightforward. Cool, let's look at the next one. This one, setting the denominator to 0 is kind of boring, right? We set x to 0 and the solving is done. So the vertical asymptote for this function will be at x equals 0. And that means the domain is everything but 0. So again, just to keep writing it in both the set builder and the interval, here is our set builder notation, all x, such that x does not equal to 0. And the interval notation would just need to exclude 0. So we'll make sure to pop over 0 like that. And that would be the domain. All of these that we're working right now can be checked graphically. If you graph them, you'll be able to see that the function avoids the vertical asymptotes that we're finding. This last example is just to kind of prevent a common error from happening. So this function at first glance appears to be rational. So let's just kind of take the same technique. We'll take the bottom, set it equal to 0. But notice that in this case, the denominator is a constant and has no variable in it. So when I set 4 equal to 0, there's no solving I can do, and in fact, I just find a false statement. This implies that there are actually no vertical asymptotes because there are no values of x that will make the denominator 0. So in other words, this is a rational function lookalike, but at its core, it's actually just a linear function in this case. What I mean by that is if I were to take the function and rewrite it just a little bit, I could bust it up as x over 4 plus 1 over 4 because both x and 1 are being divided by 4. And I could even take that a step further and write x over 4 as 1/4 x, just to make it look a little bit more familiar to you. So I'm hoping that as I just take some time to rewrite it, you're feeling like this mx plus b kind of idea. And so it turns out that the function in question 4 is actually a linear function, meaning if we were to graph it, it's just a straight line that goes on forever in both directions. So since there are no vertical asymptotes, there's no problems with the domain. So the domain here will be all real numbers. So domain is everything. No problems can occur, although the appearance of the function as rational may be thought, maybe could have made us think otherwise. So I'll say all x such that x is a real number. I'll write it that way for my set builder form. And then in interval notation, we can just express negative infinity to infinity. So that would be the domain for this one. So a good variety of types of functions here. Hopefully that helps you feel more confident with the vertical asymptote and the domain.